We're going to now take a look at the pulleys and belts section, which is going to be numbers 8, 9, 10, and 11 on activity 1.1.5. So here in a pulley system, pulley A is moving at 1500 RPM and has a different diameter, has a diameter of 15 inches. 3 pulleys, B, C, and D, all of different sizes, are attached to a single output axle. Speed and torque output are changed within the system by moving the drive belt between pulleys B, C, and D. So here's kind of a little bit of a representation. Here's pulley A looking at from a top view. We know that it has a 15-inch diameter and it's moving with 1500 RPMs of speed. So what we have is we've got 3 pulleys that are all sharing the same axle. So and here's the belt that kind of goes between them. Okay? So here's B, C, and D. Now the other way to kind of look at this too is like if you've ever looked at the top of a drill press, you could have, this is like pulley A, and then these end up being a little bit more kind of stacked like this too. So you can kind of go through and see, and then you'd have a belt that would run between the two, and you could always adjust what height and things like that. So either way, this goes through and gives us what we have. It's all the information they give us. So as we take a look at number 9, they give us a speed. A speed of 1,750 RPM is required when the belt is connected to pulley B. What is the diameter of pulley B? It's the same kind of scenario. I'm going to look at having a proportion. This time we know the diameters of we know the diameter of A, but we don't know the diameter of B. So then that way, but we do know how many revolutions per minute these things are turning. Again, watch this formula, in over out. Okay? Whereas this is out over in. This is the only one that changes like that. Okay? It's kind of the inverse. All right, so the output, diameter of B over the diameter of A, which was 15 inches, which is equal to the input, 1500 RPM, 1,750 RPM for the output for B, and then we cross multiply divide. Again, we are going to go through, as I told us before, as we calculate this out. So if you go through and you do a little cross multiply divide, 15 times 1500, then divided by 1,750. There you end up getting, we're going to go to 3 significant figures, 12.9 inches is the diameter for B. Okay? Now the next 2 problems are going to follow the same kind of formula. Okay? They're going to go through, they're going to tell us now pulley C is going to turn at 2,000 RPMs, and they want to know what's the diameter of pulley C. So this is the same kind of problem as what we did there. Different numbers, different pulley. Doesn't mean we're changing our steps. So diameter C over 15, 1500 RPM over 2000. And what we're going to end up having is the diameter for C is going to be 11.3 inches. Okay, as we move on to the back page here, same kind of scenario. We have D, we get an output RPM, speed of 3,250 RPM is required. What is the diameter of pulley D? Same kind of scenario. Different numbers, same exact formula and operation. So, diameter for D over 15 is equal to 1500 RPM over 3,250 RPM, and our diameter for D is then going to become 6.92 inches. Again, 3 significant figures for our final answer.